The third exercise in 3D is a little bit more complex, so it tried to make use of the 3D display of video and at the same time using the audio information for distortion of the 3D surface. So we start with an empty screen with a new project folder. And again, very quickly we set up the 3D environment, geometry, camera, and light. And then we also have the render from TOP. Send it back to the output. And inside the geometry, we remove the donut and put the input objects with the two buttons turned on here. And then we start to think of the display. So of course we're going to have a video device in for our live video. And alternatively, you can also use, for example, like the movie file in if you have other external video or images. Okay, and then we're also going to do the second step, that is the audio. So instead of using a pre-recorded MP3, so for this exercise I just choose the audio device in, that is the sound pick up from the microphone during this process. So what we are going to do is would like to have a video displays in 3D and using the audio information to change or to distort the surface of the 3D to have this kind of ripple effect. So for the audio, we do something similar to what we have done in last week. That is the spectrum. With the channel 1. And then we try to modify this spectrum range by doing a limit. And in the limit, we perform the normalization over here, and such that the range will be in -1 to 1 using the clamp. But even without using the clamp, you still have the normalized range between -1 to 1. And we'll do another mask for the range conversion from -1 to 1 and then map it back to 0 to 1. So the value now will range from 0 to 1 rather than the original -1 to 1. And at some point of time we may want to change the value to be a smaller one in case we need to operate with the visual effect. So in this case I just add one more mask and leave it here, and in later moment I might change the multiplication such that we can have a smaller range. And just in case we may have more to put over here before we send out to the 3D surface around here. And to play safe, I will use a null object to hold the value here first. And the next thing we're going to do is to prepare the 3D model. So instead of just using one flat rectangle, will use similar things, but it come with the grid. So the object we use is actually the grid. So grid is similar to the rectangle, but it comes with the smaller element that we can control individually. So we again try to modify the size of the grid to 1.6 and 0.9. That is 16 by 9, the aspect ratio of our video here. And at the same time, you can consider to change the number of rows and columns to correspond to this aspect ratio. So row is the Y value. So for example, you can put like 36 over here. And then for the column that's corresponding to the X dimension, we can just put 64, or you can use other smaller range like the 9 or 16, which kind of fit into the original aspect ratio. So I just used it for the testing first. So now we have the grid object. We can either directly send to the geometry, or we can make use of the video to perform make use of the audio to perform something interesting. So without the audio, you can always just put it back here. And for the video, we can just create a material that form and send our material to the geometry in render here. And remember, you can also change the diffuse color to white, such that you can have a more realistic reproduction of your video image. And the video image will go to the color map here, so you send it over here. So now we have the same result of the last exercise, that if you want to, you can rotate a little bit in the x-axis. Like, no, it's not translate, it's the rotate, yes. And also the y-axis. So in this case, you have a more 3D view of your original video display. And as I mentioned, you can also move like closer to your object, such that you have a bigger display. So the next one is how we can make use of this audio information and put it back to the 3D structure. So the action is, so we first disconnect this one and try to find out from SOP, that is the 3D related objects. Similar to the TOP, that we can use something called chop tool to create one line of pixel. We can also use chop tool around here to create a 3D model out of the number we obtain from this object. So what we are going to do is to select this chop tool and then drag our chop, that's the number, over here to the chop box, and it will show you an exclamation mark because we only have one channel over here, but the chop tool command expect 3 with the name called txtytz. Unfortunately, we don't have, we just have channel 1, so we put in channel 1, and this one still exists, the exclamation mark, because expecting to convert the 3 channels X, Y, Z into the point of the position of X, Y, Z for the 3D objects. Since we only have one channel, we can only control, like for example in this case we'll control the Z position of the point in our 3D objects. So the PO, P1, P2 correspond to the X, Y, Z position. So as I mentioned, I just want to play around with the Z dimension. So I will just remove the P0, P1 and keep the P2. And the last step is we try to remap or resample the chop and make it like correspond to the number of the pawn in the chop over here, and also we compute the normal and compute the tangents in order to have a better reflections of light. So now we have 3D objects, so you can look at the chop tool in 3D view. So you have this changing number that correspond to the audio signal over here. So what happens if we just drag the grid over here and then drag the output of chop tool to the geometry, and we immediately create this bizarre output. And it is because the range of the number may be a little bit too big, as I mentioned. So this is between 0 to 1 here, and the range of this 3D object is actually quite small, 1.6 to 0.9. So in this case we may consider to reduce the size by multiplying like 0.1, such that you have a more or less significant change in the Z dimension. So the display will be something like this. So if you talk, pop, 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 so you will have this kind of ripple on top of your video image. And if you still consider this too exaggerated or too much, so you can further reduce it like to 0.05, and then you can finally turn on the perform window with full screen without the border and go back, save, and then for a final display like this. So when I talk in front of my microphone, boom, 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 so you will notice the rippling of the surface of the video display. So this is something that you can play around with by combining the audio and video in a three-dimensional world.